Hi and welcome. In this video we'll be talking about drainage gradients and falls. For obvious reasons, all horizontal drainage pipes, both above and below ground, should be laid to an adequate gradient. If a drainage pipe is installed perfectly level, the wastewater will slow down and the solids will settle in the pipe, causing blockages. Conversely, if you install a drainage pipe with too much fall, the water in the pipe will flow too fast and leave the solids behind, again causing blockages. So what do we refer to obtain the correct gradient and falls? To achieve compliance with the Building Regulations 2010 in the UK, the approved document H, titled Drainage and Waste Disposal, was published. In New Zealand, under the New Zealand Building Code, compliance is met by following clause G13, foul drainage. In front of you are snippets taken from approved documents from the UK and New Zealand. If you now look closely, you will be able to see minimum gradients based on different pipe sizes. Now, let's decipher what the gradients mean. Let's take 1 in 40. This simply means over 40 metres, the fall will be 1 metre. What is the change per metre then, you ask? Well, take 1 metre and divide by 40, which will give you 25 mil per metre fall. A gradient may be defined as the fall divided by the distance. And if we want to calculate the fall, we times the gradient by the distance. For example, calculate the fall in a 50 metre section of foul water pipe if the gradient is to be 1 in 80. Firstly, convert the gradient of 1 in 80 to a number instead of a ratio. Therefore, 1 divided by 80 equals 0.0125. The fall then equals 0.0125 times 50 metres, and the fall is 0.625 metres or 625 millimetres. And that concludes this video. Thanks for watching.